Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from summer 2023. This paper is worth 120 marks in total, and this is the third video of 6. It will focus on questions 9 to 13, which account for 24 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 9. A factory makes loaves of bread which are wrapped in packaging. Independently, for any loaf wrapped in packaging chosen at random, the probability there is a fault with the bread is 0.02. The probability that there's a fault with the packaging is 0.01. Complete the tree diagram to show this information. Okay, so we've got branches for bread and then packaging. So we're dealing with faults or no faults for bread and then faults or no faults for the packaging. Now we need to remember that these branches need to add to 1 because probabilities sum to 1. It's told us that the fault with the bread is 0.02. That's good. So now we just need to do 1 subtract 0.02 to find out the probability that there is no fault with the bread. So 1 subtract 0.02, which is 0.98. So I'm going to write that probability nice and clearly there. Next it says the probability that there's a fault with the packaging is 0.01. So a fault with the packaging is 0.01. Okay, so I'm going to fill out the fault in both fault sections in the packaging. Now it's these sets of branches here that have to add to 1, not all of these. So 1 subtract 0.01. So we're doing 0.99 and 0.99. So we've completed our tree diagram. Part B, a loaf wrapped in packaging is chosen at random. So we're dealing with packaging here. So a loaf wrapped in packaging is chosen at random. Calculate the probability that neither the bread nor the packaging has a fault. Okay, so we're dealing with the probability that the bread has no fault and the probability that the packaging has no fault. So the probability that the bread has no fault, we're going to start here, is this strand, so 0.98. The probability that the packaging has no fault, so bread has no fault, packaging has no fault, is 0.99. And means to multiply when we're working with probabilities. So we're going to multiply those probabilities because we multiply across the branches with tree diagrams. So 0.98 multiplied by 0.99 is 0.9702. Apologies if you can hear my little dog snoring in the background. Okay, part 2. Calculate the probability that either the bread or the packaging has a fault, but they don't both have a fault. Okay, so we're not doing fault, but we do want bread has a fault, packaging doesn't. Bread doesn't have a fault, but packaging does. So either the bread or the packaging, but not both. Okay, so probability that the bread has a fault, but the packaging does not have a fault, and the probability that bread doesn't have a fault, but the packaging does have a fault this time. So we're looking at those two probabilities. So the probability that bread has a fault is 0.02 multiplied by packaging not having a fault, which is 0.99. .0198. So this time it's the probability that the bread doesn't have a fault, 0.98. multiplied by the probability that the packaging has a fault, which is 0.01. Ooh, standard form, wonderful. So that is 0.0098. Okay, so we want the total of these probabilities. So we want probability of this or this. So with and it's multiply, with or it is add. So we're going to add those together. So we're going to add that to 0.0198, which gives us 0.0296. Question 10. In this question, all lengths are in metres, so that's important. Let's make a note of that. That's helpful. All lengths are in metres. The diagram shows Terry's garden. So we've got Terry's garden here. We've got a lawn and a patio. The diagram's not drawn to scale, so remember we can't accurately measure anything from this diagram. So the patio is a square, so that's this here, and the lawn is a rectangle, which is the lawn here. The area of the lawn is 172.8 metres squared. Use an algebraic method to find the area of Terry's patio. Okay, so we're going to have to use algebra, so we're definitely going to be forming some expressions, equations, and then potentially solving. So let's see what we know. Let's form an equation for the area of Terry's lawn, because we've got all the information we need. We've got the length and the width, so length times width for the area of a rectangle equals this. So area of the lawn. So we would do the length, which is 5xy, multiplied by the width, and that would give us an answer of 172.8. So we have an equation that represents the area of the lawn. Now let's look at the patio. Okay, so let's work with the patio. So the patio is a square. So this is a square, so all four sides are the same. So actually, even though this side's labelled as 4x and this side's labelled as y, we can say that y is equal to 4x. Okay? Y is equal to 4x. And the area of the patio would be 4x squared. Okay? Bear with me. So now we have an equation for the area of the lawn, an expression for the area of the patio. However, we don't know what x and y are. Well, actually we do. We know y is 4x. So I'm going to use that fact that y equals 4x in the equation for the area of the lawn. Because what I need really is to solve and find the value of x or the value of y. Because then I can substitute it into my patio expressions and then find an area, the area of the patio. So I'm going to substitute that 4x in wherever there's a y here. So on the front we've got 5x times 4x, so y is 4x, multiplied by x plus 4x, because y is 4x, which is 172.8. So 5x multiplied by 4x is 20x squared, and x plus 4x is 5x. I'm going to continue simplifying this, guys, because 20x squared multiplied by 5x squared gives me 20 times 5 is 100. X squared multiplied by x gives me 100x cubed equals 172.8. Okay, we're getting somewhere. It's looking nicer. I am now going to solve this equation for x, because once I know x, I can find the area of my patio. So I'm going to divide by 100. So x cubed equals, when I divide by 100 here, 172.8 divided by 100 is 1.728. I'm isolating x, I'm solving for x. The inverse of cubing would be to cube root. So when I cube root this side, I get x. When I cube root this side, so let's do, move my paper, let's do the cube root of 1.728 is 1.2. Okay, so x is 1.2. So now I can find the area of his patio because I know the x value. So the area of the patio is 4 times 1.2 all squared. So let's times that by 4, which is 4.8 squared. So let's square that, which is 23.04 meters squared. So on my answer line, we're going to put 23.04. question 11, rearrange this formula to make y the subject. So we want to rearrange this, so instead of being a equals, we get y equals. So let's do this a step at a time, just to be careful and be accurate. So the first thing I'm going to do is I'm going to expand this bracket because I'm aiming for it to be y equals. I'm aiming to isolate y, and while it's inside that bracket with another term, that's going to be tricky. So we're going to expand the bracket. So a equals 7 times x is 7x. 7 times positive y to the power of 5 is 7y to the power of 5. And then we've got plus 2. So now what I'm going to start doing is I'm going to start isolating that y term. So I'm going to aim to get this y term on its own. So the first thing I'm going to do is I'm going to subtract 2 from both sides. So a subtract 2 equals 7x plus 7y to the power of 5. I've subtracted 2, so it's gone. Now, I'm still aiming to isolate this 7y to the power of 5 on its own, so I'm going to eliminate the 7x from the right-hand side. So to do that, it's a positive 7x. I know it's a positive 7x because there's no negative sign there. I'm going to subtract 7x. So when I subtract 7x here, so it's a, subtract 2, subtract 7x equals, and then when I subtract 7x here, it just leaves me with my y term of 7y to the power of 5. Okay, now I'm trying to isolate y. I'm aiming for y equals, so I'm going to divide by 7 because this is 7 multiplied by y to the power of 5, sorry. So when I divide by 7, that will just give me y to the power of 5. But what I need to do here is divide everything by 7. So I'm going to write this, guys, as a fraction all over 7, so I don't miss anything out. Fab. Next, we've got y to the power of 5. We want it to be y equals. The inverse of raising something to the power of 5 is taking the 5th root. So we're going to take the 5th root of both sides to get y. So we're going to take the 5th root. Now I'm going to write this first so that my square root sign goes all the way. Not my square root sign, my root sign goes all the way. So this is the 5th root of that whole thing. Question 12. The box plot summarises the heights in centimetres of a class of students. Use the box plot to complete the table. So we want the range, the median, the lower quartile, the upper quartile and the interquartile range. Okay, so I'm going to start with the median because the median is this line here, okay? I know the median is the middle. We're used to hearing that and it doesn't look like it's in the middle, but that's definitely the median in this box plot, guys. So let's look at this scale from 170 to 180. It's 10 little squares, so each little square must be 1. So that's 170, 1, 2, 3, 4. So the median is at 174. Now I'm going to do the lower quartile. So the lower quartile is this first part of the box here, this first line. So when I read down here, we go 160, 165, 6, 7, 168. I'm then going to do the upper quartile, which is this end of the box, this line. So when I read down here, 1, 2, 3, 4, 5, 6, so that's 186. Okay, the interquartile range is the difference between the upper quartile and the lower quartile. So let's subtract those from each other. So 186 subtract 168. So the interquartile range is 18. The range is the difference between the highest and the lowest. So the highest is 192 and the lowest is 158. So 192 subtract 158, which is 34. There we go. Question 13. Enya's house is put up for sale at the start of April. It does not sell. So at the start of May, the sale price of the house is reduced by 20%. At the start of June, the sale price is reduced by 15% of the price at the start of May. Part A. Enya says, my house has been reduced in price by a total of 35%. Explain why Enya is incorrect. Okay, so this is a repeated percentage change question. So we're going to show why any is not correct here. Okay, so we're going to say that it's a repeated percentage change. So a 20% decrease would be 0.8, would be 80% of the original. And then a 15% decrease would be 0.85. Okay, 85%. So to start off with, we're reducing the house to 80%. So at the start of May, the house is at 80%. So it's 0.8 of its original price. But then at the start of June, we're reducing it by 15% of the price at the start of May. So we're reducing the 80% by 15%. So we will have done a repeated percentage change. So when we do that, we'll have been reducing 80% of the original value by 15%. So it's actually 0.68. So that's actually a 32% decrease, not a 35%. So if you just say it's a repeated percentage change, show a little bit of working out, you're going to get those marks, guys. Okay. Next, part B. The house is then sold for £306,000. What was the original sale price of the house at the beginning of April? Okay, so we're doing a reverse percentage here, guys. So I'm going to do one of my proportion tables to organise my information and my thinking. So this is the price and this is the percentage. So the house was sold for £306,000, but it was sold at 68% of its original price, okay? So that's 68%. We want to know what the original price was at the beginning of April before any of these percentage changes. So we're aiming to get to 100%. We want to know what the original 100% was. So the first thing I'm going to do is if I divide by 68, that will tell me what 1% is. But I need to do it to the other side. So 306,000 divided by 68. 4,500. Oh. So that's 1%. So to find the original, I just times that 1% by 100. So if I times this by 100, no, that's 1,000. It's 450,000, and that's my answer. That's the original price.